Welcome, this is IBDP AAHL Time Zone 2, Paper 1 of May 2022. Question number 12. It has been given Z1 has been given and Z2 has been given. He is asking show that Z1, Z2 star. So for that, what am I going to do? First, I'm going to try Z2 star, which is going to be R2 e to the power of I theta. Now Z1 Z2 star is going to be R1 e to the power of I alpha times R2 e to the power of minus I theta. So it becomes R1 R2 e to the power of I alpha minus theta. Now in part B, real part of Z1 Z2 star equals to 0. Show that it is a right angle triangle. So what is the real part will become R1 R2 cos of alpha minus theta will become the real part, that equals to 0. So cos of alpha minus theta equals to 0. So alpha minus theta equals to cos inverse 0, which is going to be pi by 2. So therefore it is a right angle triangle. Now it is an equilateral triangle. Express Z1 in terms of Z2. So I want to express Z1 in terms of Z2. It is an equilateral triangle. So equilateral triangle means R1 equals to R2 and the angle is pi by 3. All angles are 60 degrees. So Z1 upon Z2 is R1 e to the power of I alpha divided by R2 e to the power of I theta. We know that it is an equilateral triangle. R1 R2 gets cancelled, e to the power of I alpha minus theta. But we know that it is an equilateral triangle, so therefore it is I pi by 3. So Z1 equals to Z2 e to the power of I pi by 3. Next, hence show that Z1 square plus Z2 square equals to Z1 Z2. Z1 square plus Z2 square. What is Z1 square? Z1 is Z2 e to the power of I pi by 3 whole square plus Z2 square. So it becomes Z2 square e to the power of I 2 pi by 3 plus Z2 square. Take Z2 square common, e to the power of I 2 pi by 3 plus 1. So it becomes Z2 square e to the power of 2 pi by 3 is cos 2 pi by 3 plus I sine 2 pi by 3. I write it out one more step, cos 2 pi by 3 plus I sine 2 pi by 3 plus 1. Cos 2 pi by 3 is negative 1 by 2, sine 2 pi by 3 is root 3 by 2 plus 1. So it becomes Z2 square 1 by 2 plus I root 3 by 2. So again it becomes Z2 square cos pi by 3 plus I sine pi by 3, which becomes Z2 square e to the power of I pi by 3. Z2 square e to the power of I pi by 3 can be written as Z2 times Z2 e to the power of I pi by 3. What is Z2 e to the power of I pi by 3? Which is Z1. So Z1 Z2. That's going to be the answer. Now part D and E. Z square plus AZ plus B equals to 0. Then show that A square minus 3B equals to 0. Part D. What is that? Z square plus AZ plus B equals to 0. Now what I have to prove that A square minus 3B equals to 0. So for this I know sum of the roots. Sum of the roots is Z1 plus Z2, which is equals to minus A. Product of the roots is B. Squaring on both sides, A square equals to Z1 square plus Z2 square plus 2 Z1 Z2. But Z1 square plus Z2 square is nothing but what? Z1 Z2 plus 2 Z1 Z2. So A square equals to 3 Z1 Z2. But what is Z1 Z2? Z1 Z2 is B. So A square equals to 3B. A square minus 3B equals to 0. Now in the next part he has given it out, part E, A square Z square plus AZ plus 12 equals to 0. Means what does that becomes now? A square minus 3 times 12 equals to 0. So A square equals to 36. So A equals to plus or minus 6. Now for that, first of all, I consider a equals to -6. If I consider a equals to -6, it becomes z square minus 6z plus 12 equals to 0. So z will be equal to minus b plus minus square root of b square minus 4ac upon 2a. So z equals to 6 plus minus square root of -12 upon 2, which is 6 minus plus or minus 2 root 3 I upon 2. So one value will be 3 plus root 3i, another value will be 3 minus root 3i. Now for this, it is in first quadrant, so it becomes tan inverse of root 3 by 3, which is 30 degrees pi by 6. For this one, it is over here, so the angle is going to be this entire thing. This is 30 degrees, so it is going to be 330 degrees. Tan inverse of negative root 3 by 3, which is 330. 330 means 11 pi by 6. So now this is alpha and this is theta. So alpha minus theta will become pi by 6 minus 11 pi by 6, which is minus 10 pi by 6, which is minus 5 pi by 3. So, but alpha minus theta lies between 0 to pi. Therefore, this angle is rejected. This is not possible. Now I try for a equals to positive 6. So it becomes z square plus 6z plus 12 equals to 0. So z equals to 6 plus or minus square root of b square minus 4ac upon 2a. So z equals to 6 plus minus square root of negative 12 upon 2. Z equals to 6 plus minus 2 root 3i upon 2. So z1, what do I get it out? z1 equals to, this is minus 3 minus root 3i, or so let me write it out in a smaller way so that I can create a space for this. z1 equals to minus 3 minus root 3i. So over here, how does it look? It is in this quadrant. Both are negative, so this is 30 degrees. So this entire thing, tan inverse of negative root 3 by negative 3, it is 210. 210 means 7 pi by 6. Whereas z2 will be equals to minus root 3 plus root 3i. X is negative, y is positive. So I'm going to take it out over here. This angle is 30 degrees. So this particular angle, tan inverse of root 3 by negative root 3, which is 155 pi by 6. So this is alpha, this is theta. So alpha minus theta is 7 pi by 6 minus 5 pi by 6, which is pi by 3. And it lies between this range. So therefore, there is only one equilateral triangle. So that completes this paper. See you in the next paper. Bye.